This video is sponsored by Thai Fat Lemons, Amazon Prime Delivery, Rachel's Science Gear, my Japanese school textbook, and Cat. Have you ever thought about how batteries are everywhere in today's society? I was thinking about it. They're in things like our phones, our laptops, the remote controllers that bing power on our TVs, very important, and other devices. And are very crucial when we turn on our cars. They are truly one of the most epic, powerful, and important tools in our everyday lives. But what do batteries need? Batteries need 2 electrodes and 1 electrolyte to function. Electrodes are metallic substances that can conduct electricity. Usually there is a positive or a more positive and a more negative electrode between the two, and this charge difference allows for the electrical flow to occur. An electrolyte is usually an aqueous solution that is acidic, and electrons can actually easily pass through it. So in a conventional household battery, this is battery acid, but any other acid can work. The 2 electrodes and electrolyte are key to making electricity and for the conversion from chemical energy to electrical energy within the battery itself. There's a lot of crazy stuff going on in our conventional household batteries, but because it's contained, we can't actually see it with our own eyes. So, experiments like the lemon battery experiment help us understand what is going on with batteries. In a lemon battery experiment, the lemon, or the lemon juice, acts as the electrolyte because it is quite acidic. And then there is usually zinc and copper both inserted within the lemon so that it touches the lemon juice itself. In this specific example right here, I am using a galvanized nail coated in zinc and then a copper penny. Look, there's Abe. And the charge difference is key. Zinc is more negative at this stage and copper is more positive. 2 electrochemical reactions drive this electrical current. First up, we have the reaction between zinc and the lemon's acid. So what's really going on here, can you see, is that the zinc reacts with the lemon juice and readily wants to give away electrons. So as you can see, the electrons begin to pile up on the nail. And look over at Abe Lincoln over there. Abe really wants those electrons, but there's really no way for the electrons to get over to him. So this is when we need our conductor and our connector. When we add a conductor and connector, like copper wire here, it comes to the rescue because it allows us to connect the nail to Abe, and this, along with the charge difference, the nail being quite negative and at the time the penny being quite positive, allows for an electron flow to. So we connected the copper wire and the electrons are really happy, so is Abe, because they're flowing from the nail through the copper wire to Abe. But actually they move past Abe and into the lemon juice. This is when the second reaction happens. The second reaction is between the electrons that are now in the lemon juice and the positive ions are protons from the lemon juice itself. This reaction forms hydrogen gas, which ends up bubbling out of the lemon battery. This entire exchange of electrons is, you guessed it, called a redox reaction. This cycle repeats itself, from the electrons moving from the nail, through the wire, through Abe, back into the lemon juice. And as it repeats and the electrons continue to flow, electricity is created. No way! Looks like life gave me lemons, so I guess it's time to make some batteries.